So as of now, what we have discussed, we create a node. We create a node that is which will be a root node, and after that we have discussed about the insertion of the node either in a left hand side or in a right hand side, and after that we have seen the operation to how to delete a node. How to delete, if you are deleting this particular node, we've seen the algorithm that how to delete a node. We are not into enter into the programming part. Just we have what we have done. We have seen how to create a node, how to create insert a node in a tree, and how to delete a node in a tree. And this type, that is this coming operation is called as traversal. It means this tree want to travel from the root node to the final leaf node. Like that kind of process will be happen in the tree. It means it will be start traversing from root node to the end of the leaf node, to the end of the leaf node. That will be your traversal method. In that traversal method, so this is one of the thing, you want to get an output based upon this traversal method. What in the program, what we will do, we will create a node, and we will create a left child, we create a right child, and after that the n number of left child and right child will be created as per the nodes concern. And after that, if you want to get an output in a screen which used of this traversal method, and this traversal method which will be consist of three types. One is in order, pre-order, and post order. And one more thing will be there, it will be a constant thing, that is breadth level or level order traversal. So these are the four. This three will be the major, and this as usual it will be considered as a level order traversal. So that will be the thing. So this three will be the major. So for this three, we having some of the algorithm for this three. So based upon the algorithm, the final output of your tree will be displayed in your program. So before going to that, before going to the order traversal, can you tell me the difference between the linked list and the tree? Whatever you have heard in the theory part about the tree, you have studied the theory as well as the coding part about the linked list. Can you able to imagine what is the difference between the linked list and the binary search tree?
Sir, in linked list, it passes the address of the location next up.
Yes.
But
Apart
here
from
the tree can, but tree here no address of the
no, tree will having an
before
address.
node.
Tree is having an address. I have not entered into the programming part. Tree, the structure of the tree will be like this. Structure of the tree will be like, I am just giving an for example oriented, I am giving this. So structure of the tree will be like this. So where it is, so here, so this is the, so you can see here, this is the linked list, right? Yes.
Yes, sir.
So here you can see the structure of the tree will be like this. So when you are entering into the programming concept, the structure I will be explaining. So before that, I have telling you the structure will be like this: the root node, and this will be the address of the right node, and this will be the address of the left node. And if there is no left node or right node available for the particular node, then that will be considered as your null node. So this is the structure of the linked list, singly linked list, doubly linked list, circular linked list, whatever it may be, that operation you can occur. So this is the structure of the linked list, and this is the structure of the tree. So can you tell me the difference why we are going with this linked list? Apart from linked list, why we are going with this concept of tree?
So it is hierarchical.
Yes, it is an hierarchical. What is the use of hierarchical when comparing to the sequence?
It goes step by steps.
Linked list.
Yes, sir.
Linked list will be causing of step by step. And what about the tree?
Sir, it gives the exact details, exact steps following here in hierarchy.
Yes, somewhat. Yes, it will be fine. So that will tell you
Take shortest path.
to pay the to search the
Shortest path to find the element.
yes, to finding out the
Index of
shortest.
the element.
Yes, good. So the finding out the shortest path method. If suppose you just imagine I am written a program for linked list as well as by the program for tree with this three element, that is 3, 1, and 7. Then what I want to do is I want to search an element called 7. So what the linked list will be do?
It will take the first element and it will go to step and take one and
Yes, what the linked list will be do, it will be starting point will be the index 0, and after that it will go to the next index, and after that it will be checking whether it is yes 7 is equal to 1 or not. No, it will go to the another second last element, and it will find out 7 is present here. And what the tree will be do?
So the number will check with root node, sir.
Yes, it will be checking with the root node. First it will be checking with the root node, and after that it will find out whether the root node is greater than or less than the key value. If it is greater than, it will go directly and search in the right side value. If it is less than, it will go directly in the left side, and it will find out the left side value whether the key is present or not. So this is the simple difference between these two things. And can you give me an example for this linked list and as well as the tree in real time example? How you want to insert n number of element in a linked list? So which type you will be preferring for linked list, and which type will be preferring for the tree? Real time example. So I will give you 1 minute time. Can you tell me a real time example? If you want to enter some of the details or some of the numbers in a linked list concept, which type of example you will be inserted in the linked list concept, and which type of example you will be inserted in the tree concept?
sir marks, student marks,
Student mark, which will be inserted in?
linked list also.
Yes. Then what about tree? Student mark or student register number, it may insert it. If you are having 60 register number, then what we can able to do is you can go with the 60 number starting from 1 to 60. If you want to identify that particular 45 or 46th number in your class, then what we want to do, you can directly give an index value and you can identify. If suppose the roll number has been mixing over here, if you, in your class you having 60 members and you having the roll number till 100, then the better way is going in the linked list tree concept. If you are having 60 roll number 1 to 60, all the 60 members has been arranged in the sequence order, then you can go with the linked list concept. If your class having 100 numbers but only 60 students are available, some of the numbers has been left out, in some of the register number has been left out in this class, then you can go with the tree concept. That will be useful. If your data is sequence, then you can go with the linked list. If your data is not sequence, then you can go with the tree concept. Are you getting my point? Yes.
Sir.
Yes, it means based upon the input, how the input will be given to you, that based upon that input you want to identify whether I want to go with the linked list concept or whether I want to go with the tree oriented binary search tree concept. So that is the thing. Before going to the program, we want to decide how it will be happens. So that is the difference between the linked list as well as the tree. And now coming to the traversal method. So what we have done, we have created a root node, insert the node in the tree, and we have searched and we have deleted. Now we want to traverse and we want to give an input from the first root node to the leaf node. For this thing, we are using 3 types of traversal: in-order, pre-order, and post-order. So each will have a different condition. So first we will look into the in-order statement. So in-order is the traverse the left subtree. First it will be traversing all the left subtree. You just keep that in mind. 3 different types of traversal will be. So first algorithm will be it's starting the traverse from the first left subtree. So left subtree, all the left hand side will be covered, and after that it will be visiting the root, and after that it will be traversing the right subtree. So first, what is the thing is, for in order, it will first find out the left element of the root. By traversing technique, first it will find out the left element of the root, and after that it will be concentrate on the root node, and after that it will be moving to the right node. So this is the concept. Yes, I will give you an example how it will be traversal, but the concept is clear, right? What is mean by in? So normally the tree structure will be left, root, and right. Am I right? Normally the tree structure will be left, root, and right. That is the tree structure. I hope so. You have normally the tree structure. If you are having on binary tree, normally the tree structure will be left, root, and right. That is known as the in order. The traversal method will be like this. It will be traverse to the left hand side, and after that it will be traverse all the root node, and after that it will be traverse the right hand side. So that is the concept of in order. I will give you an example after completion of all the process. And now coming to the post order, in the pre-order, it will visit the root first, and after that travel to the left subtree, and after that travel to the right subtree. So that is the concept. So it will visit the root first. So pre-order will visit the root first, and after that it will go to the left subtree and right subtree. So this is the pre-order. So when you are searching an element over here, that when you are traversing an element from there, it will visit the root element first, and after that it will go to the left child, and after that it will go to the right child. So that is the process. And now coming to the post order, it travels left subtree. After that it travels the right subtree, and after that it will visit the root. So that is the process of the post order. So yes, now you can understand the concept, right? I will give you an example. Before going to the example, have you understand this concept? So in order, in the sense, it will be in the same order with the tree structure. Normally the tree structure will be left, root, and right. That is the tree structure. So that will be in order. So pre-order, the root want to be coming first. So it is known as the pre-order. So the root will be coming first. The root will came first, and after that the left and right will be accessed. And post order, the root will be going to the end. So left, right, and root. So that is the concept. So you just, when you are want to remember this thing, you will mention this root where the root has been occurred, and remaining you can able to understand easily. So in order, the root will be in the center part, and pre-order the root will be in the first part, and post order the root will be in the last part. Clear about this? Yes.
Yes,
Yes. So now now we will move with an example here. So now you can tell me what is meant by in order.
left root, right.
Yes. So what is the left?
So it's
No.
2, 4.
2. No.
4.
Yes, 4 is a left. The 2 is not a left. 2 is a root of 4. The 2 is having the root as well as the parent of 4. So 2 will not be considered as left. So 4 will be considered as left. So now first element will be 4, and after that left, root, and right. So 2 is a left child also as well as the root also. So first you will take the 2, and after that you will take the 5. First this part want to be considered. First what you have done, so this is the overall tree structure. In this tree structure, this will be your left, this will be your left, and this will be your right. And after that what will happen, this will be your left, and this will be your right. So first whatever I have mentioned in the yellow color, we want to do that. So it is left, root, and right. So this left has been completed, and after that for this one particular root 1, we want to find out this left has been completed, and again we will go with the root 1 and 3. Clear, or any doubts is there? Any doubts? Or I want to explain it one more time.
Sir, first we want to complete all the elements in left hand side. Sir.
Yes, first we want to come. That is the in order process I have told you that in order, first we want to complete all the elements in the left hand side. And after that, the root want to be, the main root want to be considered. And after the main root, the right want to be considered. So that is the thing we have done.
Right has left or right. If tree has a left and right palisade, then what we do?
Yes, I will tell you first. That process I will tell you. First, you can understand the concept now.
Yes, sir.
Yes, if the tree having any child, that I will give you another example also.
Okay, sir.
Yes. So this is the thing for four, 5, 1 and 3. So now coming to the pre-order. What is mean by pre-order?
Root
left,
first, sir.
root, left, right.
Root left, right.
Root left and right. So that is the pre-order. So what is the main root?
1.
1.
1. So 1 has been completed. The root has been completed. Now we want to focus on the left hand side. So left hand side, what is the root now?
2, sir.
2. So root has been completed. And after that, the
4.
left part want to be completed. 4. And after that, 5. And after
3.
that, 3. That is the pre-order. Are you clear?
Yes, sir.
Yes. What is the structure of post order?
Left, right, root.
Left, right, and root. So first the root element left will be these 3 things, and this is also a root. So this is considered as your left. So first will be 4, and after that 5,
2,
2,
3,
3,
1.
1. So that is the thing.
3.
So this is the traversal method. So first we want to find. So I will. If you are not understand, you just wait. I will tell you with another example also. So this is the traversal method. How this will be traveled till it will look into the first depth leaf node of your root, and after finding out the leaf node, it will give you the process of whether you want to go with in order, pre-order, or post order. That will be. It will be taken first. If you are going with the right, it will take the right leaf node, and if you are going with the left, it will take the left leaf node. So that is the process. So most probably we won't start with the right node. It will be starting from the root node, or it will starting from the left node. So that is the concept. So if you understand about this, we will move on one more example also.
Yes, sir.
Yes. So in this case, what is the, and for easily identifying whether it is a fully binary tree?
Yes, sir.
Yes. So if suppose I am having 2 elements over here, whether it is a fully binary tree?
Yes, sir.
Yes. So here the level of all the binary tree has been completed without any left alignment also. So you just imagine if suppose I am having this 2 number over here, 0 and 0. So you just imagine if suppose I am having 2 numbers, so I am giving this as 0 and 0. Just imagine, don't take the number. So it will be coming at the last. You just imagine. So in this case, you can see here where the root node has been occur. If it is a full binary tree which consists of all child and all parent, you can see here where the root node has been occur. This root node has been occur in the mid of the position. Here the root node has been occur in the first element, and here, so the one will be coming at the last and finally if you are having this element. So here the root node will be in the last element. So that will be the process. What we have given in the previous, what we have given in the previous thing, what I told here. So, root will be want to be in the middle, root want to be in the first, and root want to be in the last. So in the next example we will see that. So now for this you can tell me the pre-order, post-order and all. You just take the paper and pen and you can tell me that. So first we will start with the in-order. So what is the in-order technique?
For
What is the in-order technique? First you can go with for starting
root,
you will go
Left root, right.
left root, right.
left root and right. Left root and right. So first, what is the left over here?
4.
4. Then
10.
10.
12.
Then 12. Then so here you can see here first. This is the root node, and after that you have gone with the left hand side, and after that you have gone with the left hand side, and after that you have gone with the left hand. So this is the leaf node, and after finding out the leaf node, the 4 has been written here, and left, root, and right. So this part has been completed. So for this root node, this left hand side has been completed. So that is the process. And after that, what we want to write? Left.
15.
Yes. So after that, the 15 want to be written here because this part has been completed as your left, and after that the root part want to be written here, and after that it will traverse to the root part. So what will have what will be the next?
18.
22.
18.
18.
Yes. So 18. So root.
22.
This is the root of this particular thing. So 18, 22, and 24.
24.
Am I right?
Sir, why you written 15, sir?
15 is the root node for so for this will be the child node, right? For this and this will be the root node, and this will be the left side, this will be the right side. After completion of this left side, you want to write the root node, right? Are you getting my point?
Yes, sir.
Yes, sir.
After completion of this, you consider this is my root node, and after completion of all this left, I want to write a root node, right? Here all this left has been completed, so it means
Yes,
4,
sir.
10, 12 has been completed. So I want to write a root node, and after the root node I want to traverse to the right node. In that right node I want to first find out that left, root, and right. After completion of all the things, all the elements has been completed. So that's why I have written 18, 24, and 22. So all the element has been completed.
Yes, sir.
Yes, and after completion of all the left hand side, what will happen? It will go to the root node, right?
Root.
Yes. So it will be 25. Am I right?
Yes, sir.
Yes. And now you will come to the right hand side. And first, when you are coming to the right hand side, it will traverse to the left, and again it will traverse to the left till the till the leaf node. So leaf node, what is the leaf node now?
31,
So 31,
31, 35,
35, 44,
35,
44,
44,
50,
50,
50,
66,
66, 70, 90.
70, 90,
66, 70, 90.
90.
That's it. So that is the in order. So I will tell you this. So first, this 4, 10, and 12, which causes of this node, that is the final leaf node, this 4, 10, and 12. And this 15 will be the root node. This 15. After this 15 will be the root node. And after this, 18, 22, 24 is your right side node. Now the process has been completed of left side. Now what we want to do, the condition for in order is left, root, and right. So left side has been completed as of now. Now we want to write the root node. So the root node has been occurred here. And after that, this process will be first taken 35, 31, and 41. So that is written here 35. So this is the root node, this is the left, root, and right. So 31, 35, 44. And again we want to traverse to the root node, that is 50. So for this 50, we completed the left hand side. Again we want to traverse to the right node, that is 66, 70, and 90. So that is the thing. Are we clear about this?
Yes, sir.
Yes. Now coming to the pre-order.
Root left, right.
25.
One minute. Yes. Now coming to the pre-order.
Root left right.
So pre-order, which will be root
Left, right.
left and
Right.
right. So that is the pre-order. So first we want to what we want to look into it. First we want to write the root, right?
25.
Yes, sir. 25.
So 25 is my main root, and after that I want to traverse the left hand side. So 15 is my main root. Again we will find out whether any root
10.
available or not. 10 is my main root, and again I will go to the
4.
4, 12.
left hand side. 4, 12. Yes. After completion of this, so now I will tell you that. So first, this process has been over. That is, the pre-order is root left and right. So first I have taken the root, and it want to be traversed till the leaf node, right? So it will be traveling till the leaf node. That is, second root will be 15, and after that the normal position will be left. So the third root will be 15. So after that 15, the leaf node has been occur in the left hand side. So we want to first, so root has been completed. We completed all the root in the main root as well as in the left hand side root. Now we are going to traverse with the left hand side. So it means 4, 12 has been completed. So as of now, this part has been completed now. Are you clear?
Yes, sir.
Yes. As of now, this part will be, as of now, this part has been completed. It means we taken a root, and in that left hand side, we having another root. For that root, we having a left hand side. For that root, we having a left hand side. So we have taken 3 roots and 2 leaves. So we have taken 3 loops and 2 leaves. So that is the concept. Now after completion of this, after completion of 12, what will happen? So here what we have done, taken the root, taken the left, and completed the left. And after completion of 12, what will happen?
Sir, for
It will
15
go to
another root is there.
Right.
15
Right.
right want to be considered. So right root node will be 22, and left node will be 18, and right node will be 24. Clear?
Yes, sir.
Yes, sir.
Yes. So in that case, what will happen is, in this case, what is the thing happening is, we have completed this all the thing. It means we have completed the root, we have completed the left, right? So now we want to complete the right hand side. So right hand side, same process, right, left, and right. So for going with the right hand side, what will happen now? 24.
50.
So first root will be 50, and then
35.
35,
35,
31.
yes,
31,
35,
44,
31,
44.
44,
70,
70,
66.
66,
90.
90.
90.
So that is the structure. So yeah, 66, 70. So 66, 70, and 90.
Yes, sir.
66, 44,
70, 66 only, sir.
Sir, root
70
left,
is
right.
root.
40. No, 1 minute, 1 minute, 1 minute. We're done with 24, right? We're done with 24. And after that, it will traverse to the 50. Am I right?
Sir,
It will traverse
50.
to the 50, and it will
35.
traverse to the 35. And after that, it will be
31.
traversing to the 31. And again, it will
44.
traverse to the 44. And again,
70.
it will
70.
traverse to the 70,
66. 90.
66,
90.
90. So that is the thing for pre-order. Now I will tell you that. So here, this out of this 24, what is the thing is? Out of this 24, yes. Out of this 24, what is the thing is? This is the root node, and this is the left side of the node. For this right side of the node, this right side will be your part. This has been occurred. This is your right side. So right side, what has happened? First, we want to take the root node, that is 50, and after that, you want to take the left side root node, that is 35, and after that, you want to take the left side. So left side is not till reach the leaf node. So after that, you want to take the left side, that is 31, and after that left, the root node want to be considered. Left, the right node want to be considered. So we have written 44, and once here, this process has been completed as of now, that is 44, and remaining it will be having the only one process. So remaining we have only one process, that is 70, 66, and 49. 70, 66, and 90. For this 70, 66, and 90, the 70 will be a root node, and 66 is your left node, and 90 is your right node. So that is the thing for pre-order. Clear? Any doubts in this? Yes. Any doubts? Am I audible?
No, sir.
Yes, sir. Audible.
Yes, sir. Audible.
Yes. So now coming to the post order, the final step will be your post order. So now coming to the post order. Now, so what is the post order?
Left, right, root.
Right root.
Left,
right,
right, and root. So this is the post order technique. Now you can tell me how. 1 minute.
4,
1 minute. 1 minute. So yes. Now here you want to find out the left, and for this root the left will be 15. For this 15 the left will be 10. So this will be the first tree we want to consider. So what is the left of this first tree?
4,
4.
4.
12,
12.
4 is my left. First we want to find out left, right, and root. 4, 12,
12. 10.
and 10. So yes, now first tree has been completed, and after that we want to look into this tree. After that we want to look into this tree. So here the left hand side has been completed. Now we want to traverse in the right hand side. Am I right?
Yes, sir.
Here I want to traverse in the right hand side. In this right hand side, this is my root and this is my left and right. So now what will be the result is 18,
18, 24,
24,
22.
22.
22. So now the thing, for this 15 root we have completed left hand side as well as the right hand side, right? So after completion of left, right, the root want to be displayed. So the 15 will be displayed here. And now what is the thing has happened? So here all
Right
the
side
things
of
has been displayed. So all the things has been displayed. So left hand side part is completed. Now what I want to do?
Right side,
Right of main root.
Right of the main root. So what is the right of the main root which will be starting from?
50.
Starting from the 50. So first you want to look into the left side of the node. So again we will go with this. So this is my first tree, right? This is my first tree. Am I right?
Yes,
Yes, sir.
So the value will be the first tree left value will be 31,
44,
44,
35.
35.
35. So the first tree has been completed. And again I want to go after left, I want to move with the right, right? For this root I want to move with the right. So what is my right value?
66,
66.
So this is my right tree. In this right tree I want to do this operation, that is left, right, and root. So 66,
90,
90. 70.
66, 90,
90,
and
70,
70.
50, 25.
And after completion of this two, I want to go with this main tree, that is 50. For that particular main right hand side main tree, that is 50. And after completion of this 50, the final element is the root call. So the final element will be like this, that is all the elements combined together, the root will be 25, and the root will be inserted in the last. Clear?
Yes, sir.
Yes. And you can check it out that whether you have done as correct or what. So for this in-order traversal, the root element will be in the center point. The in-order traversal, you can count the number, it will be in the center point. The root element will be in the center point. For the pre-order traversal, the root element will be in the first point, right? And for the post-order traversal, the root element will be in the last point. Clear?
Yes, sir.
Yes. When you want to check it, those things, whether we have done the correct traversal method, then you can check with these three things: in order, middle of the element, pre-order, first element, post-order, last element. So that is the thing. So this is the thing as of now for the traversal technique. This technique want to be implemented in your class. Sorry, implemented in your program. That is the thing. So when you are going, so we will discuss in the program in the next class. In this class I will tell you how to create a class. You already know how to create a class and how to create an object and all. So the thing what we want to do in a program point of view, you just want to create a null node, null tree. That is the first one. Sorry, that this tree will be represented like this. The tree will be represented for the pictorial representation. I have given the circle oriented thing. So the actual tree will be represented like this. So this is the tree structure. Here we want to create a tree. That is the first thing. In list, we have create a list. That is the thing. And here we want to insert a node with the condition. So what is the condition to insert a node?
Less than root.
Yes, if it is less than root, we want to insert in the left hand side. If it is right than greater than root, we want to insert in the less than we want to insert in the left, greater than we want to insert in the right. So in that condition, what will happen is the same technique will be followed for this root also, right? This is also a root, right?
Yes, sir.
Yes, for same technique, this will be followed for this root also. So in that case, the regression will be coming over here in the tree. So that is one of the major part. When you create, first you want to create a left root node. After that, the left and right. That's enough. After creating this, we do a regressive technique, and you can insert wherever element wherever they want to insert, that will be inserted over here with some of the condition greater than less than condition will be occurring in your program. So that is the tree. And finally, we are inserting all the elements. We want to do a traversal operation from the root node to the leaf node by using this three type of traversal. That is the thing. So this is the thing we are going to do in your program in a binary search tree. Clear?
Okay.
Yes. So for this explanation, I have taken 3 classes for you. Half an hour of content. I have taken 3 classes. Let's see that. So program, you will be understanding. If you are thorough with this concept, then program will be understanding. Without explaining this concept, when you are directly entering into the program, then you will be getting confused. So that's why I have taken 3 classes for this, for the explanation. So yes, tomorrow we will move with the program. First we will move with the program, and before that you all know that you just simply you want to create one of a node. So you all know that how to create a class, right? How to create a object also, right? So I am creating a class called binary search tree. So let's take this class name as BST. So I am creating a class called BST, and I am initializing an object that is init. What is meant by self? What is meant by self? What is meant by self? Am I audible? The meeting has been cut off. What is meant by self?
Calling inserts. Default argument.
Default argument, that is a constructor of an object. If you are using a self inside the class, definitely you want to create an object. So that is a concept. If you are creating an object, then you want to create an object called self. And this init function will be representing the temporary variable that will be stored all over your program. For that, we are using this init function. So init comma key. So it means self dot key is equal to key. Self dot L child is equal to none. Self dot R child is equal to none. Root is equal to BST of 10. Print root dot key. Print root dot L child. Print root dot R child. Yes. So this is a simple way of creating a constructor over here. I don't know whether this is okay. Yes. So what I have done is we have initialized an object called def init function. It means it will be store a temporary variable and it will be giving an input for the user. So initially what I have done, I have created 3 nodes. of list. I have created a 3 node of list, and in the left self one dot child, it means self one, that is we are calling the same function, that is self one is equal to null, and right child, that is left child is equal to null, none, and right child is equal to none. So that is the function I have created. And after creating the function, I have passed a key value called 10. So it means I have created a tree with the root node called 10. That is the creation of the tree. And I'm printing those things with the object. So what is my object here? What is my object?
Root.
So root is my object. Root is my object of BST class, and based upon the object, I have called the key value. Whatever the key value first were entered into the class key, I have called. So the output will be displayed as 10, and the left child is null, and right child will be none. So this is the first step of the binary search tree to create a root node. I understand. Yes. I understand. Yes. And the next one, in the next class, we will discuss after creation of this root node, how we want to insert an element in the particular tree. And how we want to insert and delete operation will be discussed in the next class. So after that, we will go with the traversal technique. So this is the 2 things. So in the next class, we will discuss about the insertion and deletion of the particular tree. So first we have created a root node, and if I am going to, so I am taking the slide on. So here you can see the structure. So first the root node will be 10. So the root node has been inserted, and after that I want to insert the root node of 5, the node of 5, and for that I want to check whether this 5 is less than or equal to 10 or greater than 5 or whatever it may be. To avoid the duplicate element also, we want to write the program, and after that this structure want to be implemented in your program. That is the concept. So first what we have done as of now, we have just created this 10. That's it. So this insertion part and deletion part we will discuss in the next class. So when you are running this code, you will get an answer called 10. That is my key value, and none is my left hand side, and none is my right hand side. So that is the thing. So any doubts, you can stay back and ask your queries, or else you can give your attendance and attend the next class. So those who are mentioned the name, kindly stay back here. Those who are not interested to stay back, you can leave now with the only one condition, that write a letter, put a signature, and send it back to me. That will be fine. So those who are having no doubt and those who have submitted the assignment can leave, give your attendance, and you can leave now.